Over to you.
Hello? Sir? Sir, room bola, sir? Face sala? Uh-huh.
Yes, ma'am. One second, ma'am. Karthik is present.
ಹೌದು ಸರ್
Yeah.
ಅವಿನಾಶ್ ಸರ್ ನನಗೆ ಮೆಸೇಜ್ ಹಾಕಿದ್ರು ಏನೋ ಒಂದು ಸಂತೋಷ್ ಸರ್ ಕೊಡ್ತಾರೆ.
Karthik, your screen is not fully displayed. Just press F5. Now, when you go for slideshow, only the
Ma'am, one second,
title.
ma'am. I'll present.
Yeah.
One second,
Yeah.
ma'am. One second. Ma'am, now is it visible, ma'am?
No, only BMS Institute of Technology and Management, Avalalli.
No, ma'am. Like we have made the animation. Like
Okay, then go press a button. At least we'll see the full thing.
that. Okay. Okay, ma'am.
Shall I continue?
Vasant.
Yeah,
you can
yeah.
start.
Good
Karthik
afternoon,
and
everyone
team,
present.
Karthik and team, you
Yes.
are having 10 minutes time and 5 minutes for queries. Okay. So please make arrangement,
Okay, sir.
coordinate among
Okay.
yourself and try to
Okay,
complete
sir.
your presentation within 10 minutes. Okay.
Okay, sir. We'll do
Yeah.
that.
Yes. Sir, today our PBL presentation is of hydraulic energy regenerating system in vehicles by braking. This group consists of B.S. Lalit, myself Vasant Kumar, Shivkumar Patil, Tanvir Hussain, Karthik, under the guidance of Dr. Nandini ma'am. Our PPT consists of introduction, principle, block diagram and working, efficiency and application, advantages and disadvantages, and conclusion. Let us go to the introduction. Regenerative braking system are a type of kinetic energy recovery system that transfers the kinetic energy of an object in motion into the potential energy or stored energy, and as a result it increases the fuel efficiency. This system is are also called kinetic energy recovery system. This method is used since late 1800s. The first railway system used this technology was Baku Tbilisi Bhutani Railway in the year 1930s, and also an American motor car company used electrical energy regenerating braking for their concept of electric car in 1967. And the principle of hydraulic energy regenerating system is when the vehicle deaccelerates, it will store the kinetic energy in the form of pressure rather which was converted into potential energy in case of conventional system. And this process is done by using a displacement pump to pump in hydraulic fluid in accumulator. Now I call upon Lalit to explain the working of hydraulic.
Yes, sir. Yes, sir. Good afternoon to all. This is the sketch of our model. Uh, these are the general components of the hydraulic regenerating system. Now I'm going to explain the working of the hydraulic regenerating system. Uh, the system primarily consists of high pressure reservoir, low pressure reservoir, variable displacement hydraulic pump motor unit, clutch transmission, and differential. Hydraulic pump motor unit and hydraulic pump are coupled to the propeller shaft via a gear system. Now let us consider the working of the system while braking. Karthik, can you go to the block diagram?
Okay, bro. Wait, I'll explain. Now you can you see that?
Yes. Now we are going to consider the working of the system while braking. So during deceleration or braking, the hydraulic pump motor decelerates the vehicle operating as a pump to capture the energy normally lost to friction brakes in a conventional vehicle. Also, when the vehicle brake is applied, the hydraulic pump motor uses the braking energy to charge the hydraulic fluid from the low pressure hydraulic accumulator into the high pressure accumulator, which increases the pressure of the nitrogen gas in the high pressure accumulator. So what essentially is happening is that the kinetic energy of the vehicle is getting converted into potential energy and is stored in the form of pressurized fluid, pressurized nitrogen to be specific. Now let me explain the working of the system while accelerating. The high pressure hydraulic fluid is used by the hydraulic pump motor unit to generate torque during the next vehicle acceleration. The fluid in the high pressure accumulator is pushed through the pump motor, which acts as a motor in this case and uses the pressure to turn the wheels. Now the now unpressurized fluid is stored in the low pressure reservoir. So while vehicles starts and the pressure of hydraulic accumulator is higher than the minimum working pressure value, the commanded power of the vehicle is supplied only by the hydraulic pump motor. But when the pressure in the hydraulic accumulator declines to the minimum working pressure value, the vehicle is switched to cruise condition and the engine begins to supply the power. Yes, ma'am. Now my friend Karthik is going to explain the efficiency and the applications of our project.
So good afternoon to everyone. Thank you, Lalit. Now I'm going to explain the part about efficiency. Now I'm going to explain about the efficiency of the hydraulic regenerative braking system. Any part or any system without explaining the efficiency, it is like a balloon without an air. So while calculating the efficiency of a system, we need to consider while calculating the efficiency of hydraulic regenerative braking system, we have to follow certain sequence of steps that are accelerate until a certain speed. In general, we are calculating the power, which I'll show later, for 50 kilometer hour speed. So let us consider we should accelerate until 50 kilometer hour speed. Then we should brake only with the hydraulic regenerative braking system. Now, you using the same hydraulic energy, we are accelerating the vehicle. Now we'll now we'll use all the hydraulic energy. Now we'll use all the hydraulic energy to move the vehicle. So we all know the efficiency is the energy recovered to the kinetic energy at the time of braking. Now, in general, we are considering it as 50 because since we are calculating the efficiency when the vehicle deaccelerates from 50 km hour speed to 0 km hour speed. So efficiency is equal to work plus kinetic energy divided by kinetic energy at 50 km hour speed. So as we took the data from the net, we got to know the work done by the system at 50 km per hour speed is 5.903 kilojoules, and the kinetic energy is 2.755 kilojoules. So if we substitute that thing in the formula, we'll get the efficiency as 22.59%. In general, we can consider it as 22.6%. So the efficiency of vehicle at 50 km per hour speed is 22.6%, but we can increase this uh, efficiency up to 32% by proper maintenance of a accumulator, that is both a high pressure accumulator and low pressure accumulator, and avoiding the leakage in the accumulator, pressure leakage in the accumulator, and by selecting the good hydraulic fluid which has low wear resistance and which can withhold the high thermal resistance, and which has low tendency to cavitate, and which offers more resistance to water, and which has constant viscosity regardless of the temperature change. So every time regenerative braking system cannot alone guarantee the safety of the vehicle. So in case of emergency, hydraulic regenerative braking system cannot be used as a safeguard. So we have applied, what the thing we have done is we have applied a fuzzy logic system which will decide whether to apply the regenerative braking system or the conventional frictional brake. So the flow chart of this is looks like this. When the driver will apply the brake command, the physiologic system, what we are told, it will calculate the required power and it will turn on the ABS, that is anti-lock braking system, and it will give the output to the physiologic system whether the power can be supplied only by regenerative system, or it should require the high power. If the power is sufficient only by the regenerative system, then the physiologic system will not directly apply the regenerative braking system. It will do another type of verification, that is it will detect whether there is an excessive slip. If yes, then it will disable the regenerative system and will apply the conventional brake. If the calculated power is not sufficient to stop the vehicle, then it will then the vehicle will apply both the conventional braking system and the regenerative braking system. If that is also not sufficient to stop the vehicle, then the vehicle will go for the conventional braking system, that is frictional braking system. Now I am going to explain the applications part. So coming to the applications, this hydraulic regenerative braking system are used in both hydraulic and electric cars. Modern hybrid and electric cars both utilizes the electric engine to power the car, which makes applying regenerative braking system, that is hydraulic regenerative braking system, very simple and efficient. In the vast majority of this car, the transmission is set up in such a way that when the driver applies the brake, the electric car motor reverses itself and it offers the resistance to stop the vehicle. Second point is in high performance car. In high performances car, the car feel is as important as the braking system. Many customers are ready to buy the uh, system. Many customers are ready to buy the cars which are employed with regenerative braking system. They cannot buy high because of the feeling of the car. If we apply the regenerative braking system, it will not be a same feel as we apply the conventional brake. So big companies like Benz, Mercedes, and Porsche, they are planning to implement this hydraulic regenerative braking systems in a more efficient way. In auto racing, in 2009, Formula One car has employed a regenerative braking system. Was the only one car to employ the regenerative braking system. But in the later seasons, like in 2019, almost all the cars have applied this regenerative braking system. But the Federation of International Automobile restricts the use of this regenerative braking system, so that it can be only applied for 6.67 seconds per lap, which gives a car an power of 81 HP, 81 horsepower. The regenerative braking button will be at the steering of the driver. So now I would like to hand over the advantages and disadvantages part to my friend Tanvi.
Good afternoon, everyone. So, as my friend said, I am going to tell you the advantages and disadvantages part. Hydraulic regenerative braking system employs the use of saved energy. It will increase the fuel economy of the vehicle. The major, the major advantage of hydraulic regenerative braking system is it employs the lesser energy conversion rather than conventional regenerative braking system, which in turn increases the efficiency of the system than others. The hydraulic regenerative braking system does not employ the conventional method. It does not stop the vehicle by the application of friction. Therefore, it reduces the wear and tear of the system. While there are many advantages of the system, there are few disadvantages also, which are since the hydraulic regenerative braking system includes the components such as high pressure accumulator, low pressure accumulator, and the generator, which is required to store the pressure and energy respectively. So the complexity and management cost for all these components also increases. As stated earlier, that extra apparatus is required for hydraulic regenerative braking system, so it is less practical in case of smaller vehicles. Even if it's implied, the efficiency will be too low. The hydraulic regenerative braking system is not practical in case of lower speeds. So now I would like to hand over the conclusion part to my friend Shiv Kumar.
Thank you, Tanvir. Now I am going to explain the conclusion part. Braking is an extremely wasteful process as a large amount of kinetic energy is turned into heat energy. Thankfully, we got a regenerative braking system which makes use of it. Despite the amount of research and development that has gone to regenerative braking, there is still significant room for improvement. Regenerative braking is still very limited and dependent on controllable variables. Also, danger can arise if regenerative braking is applied to two-wheeler drive brake systems. However, regenerative braking does have various benefits. A proper implementation of regenerative braking system extends driving range, reduces brake wear, and improves energy conservation. Thank you.
Uh, Karthik and team. So
Ma'am?
my few Karthik and team. Others kindly mute your mic. Uh, my questions are: what is your groundwork? What you have done based on the literature part?
Yes, ma'am. We've gone through various research papers,
Mm-hmm.
and we thought this is the best way for us to use the hydraulic system, ma'am.
So
Hydraulic region.
based on the literature, you selected this way of approach.
Yes, ma'am.
So what is the improvement you're getting due to your modification? Then can you throw some light on it?
Yes, ma'am. Actually, we thought of uh, we know that about 65% of heat is energy. 65% of energy is lost as heat in a conventional IC engine. We thought of utilizing that heat uh, in the hydraulic regenerative system by through heat exchangers the heat can be supplied to the nitrogen gas inside the high pressure accumulator, but it still needs a lot of planning because we know that heat transfer doesn't takes place from lower temperature to higher temperature. So we need to plan about that. But just considering this system, where theoretically we can get an efficiency of 31%, which is significantly larger than the current systems.
Theoretically, you can get 30%.
Yes, sir.
Have you checked into the research papers wherein they have performed and demonstrated this in actual?
Yes, ma'am. We have
How?
checked the journal
Yeah.
paper.
Okay.
According to their what they have made, the efficiency can be improved up to 32%, ma'am, by
Okay.
minimizing the pressure leakages and using good hydraulic fluids.
Sir.
We can
Okay.
maximize the efficiency.
No, you should still do some better work to see exactly how you can improve the performance in experimental way as well. And one thing you have to substantiate yourself with the literature data. So, with respect to the literature, what is the percentage of improvement you are doing? As per the calculation, have you checked the paper how much they are getting and what is the improvement in the theoretical approach?
Ma'am, as per the theoretical report, the efficiency is 31%, ma'am. But
Okay.
according to the practical work they have done, it will be around 28 to 29%, ma'am.
Yeah, because always a theoretical approach will give you a more value than that of the experimental one. So you should later try to map out experimentally. But anyhow, regenerating system, there are many in the bracket. You should prove that how well your regenerating system is, how you can improve its performance, right? So still more literature work is needed. And what about the cost factor? You had told me that you'll be doing the simulation part of it.
Ma'am, the cost will be around 70,000, ma'am, 70,000 rupees. But
Okay.
actually, it depends on what vehicle we are applying this, ma'am. So
Mm-hmm.
this system is particularly efficient for heavy vehicles such as trucks.
Okay.
So considering the speed limit in our country, which is 80 kilometer per hour,
Mm-hmm.
we should design the system uh, which is efficient in our environment.
Yeah.
The simulation we tried using MATLAB, ma'am, but it turned out to be too complex, ma'am. And there was a problem with the system also. That's why we couldn't do it.
Yes, you can just think about in your near future. If you get an advanced version of a laptop with better configuration, you can
Yes,
try to work on it.
yes, ma'am.
So yeah, so that's all from my end, sir. Sundaresh and Kiran, sir, questions,
Yeah,
please.
yeah, yeah, yeah. This is Sundaresh. Karthik, see, a lot of work has been done on regenerative braking system.
Yes,
Can you
sir.
hear me?
Yes, sir. Yes, sir.
Karthik, yeah, a lot of work has been done and still it is going on. But what novelty you have brought in your work actually?
Sir, that's what Sir Lalit explained. No, a
Hmm.
lot of energy, like heat energy, is wasted in the process of engine heater. So we
That's
are
what I'm
trying
telling
to.
you. That work has been done already. That's what Madam was asking. Have you done the literature? Because I've seen many papers like that. They have taken the heat exchangers and they have already been converted. That is there any new things you are bringing into your work
Yes,
comparatively with respect to the literature? Yeah.
they are done, sir, but they have not prepared the model, like the working model, that thing. We are planning
Okay.
to do that work, sir.
Now, what is the status of your work? Have you done the model or just only the design stage only?
Sir, we are done till the design stage itself, sir. That's it.
No modeling or no fabrication work still you are not done.
No, sir.
Okay. Right. Okay. Right. That's it. Okay. Yeah.
Yes, sir. Thank you, sir.
Kiran, sir?
Okay, madam. Okay, no, no question.
Okay. Yes, sir. Yes, sir. So fine then.
Thank you, sir.
Thank you, Karthik and team. So we'll go with the next team. Bhavna DV,
Yes, ma'am.
Banu Pratap Singh, Banu Pratap,
Yes, ma'am.
Chirant,
Yes, ma'am.
Somesh Kumar,
Yes, ma'am.
and Vivekananda.
Yes, ma'am.
Yeah, so your work title is Multipurpose Agricultural Machine. You can please start now.
Yes, ma'am.
Yes. Good afternoon, everyone. To the outset, I would like to thank Nandini ma'am, our guide, and our examiners who gave us this opportunity to present our ideas. Our teammates are Somesh Kumar, Tiran PT, Banu Pratap Singh, Vivekananda, and myself, Bhavana. Now, as the theme given to us about mechanics of materials and material science, we propose to make a multi-purpose agriculture machine which also helpful for charging mobile phones. Our vision is to make a machine which will do tilling, irrigation and sowing seeds and also sprays water, pesticides and insecticides at regular time intervals. We also have found out ways how can we charge our mobile phones using mechanical energy of the rotating wheels. Our machine contains both mechanical as well as electronics parts. Now, coming to the need of this machine is to cut down the cost of production as only few laborers will be working in the fields, and it's also time saving as all the operations are carried out simultaneously at a regular interval of time. As it also includes the mobile charging part, as we know, so many students are returned to their hometown and attending classes from there. So, most of their families are working in the agriculture field. Even these students need to help their families due to no laborers in this pandemic. And they need to charge their phone at least 3 to 4 times a day when they attend classes. But there is no proper power supply in remote areas. But the advantage of this machine is to charge the phone simultaneously as the work as they do the work. So this one of the difficulties is eradicated. As keeping the theme in our mind about mechanics of materials and material science, we have thought about even choice of materials for our machine, which will be explained by our team later. Now, I would request Banu Pratap to explain briefly about the mechanical part through flowchart.
Good afternoon, everyone. So I will thanks Bhavna. I will continue from here. So basically, our machine is divided into two parts. That's the bottom part and the upper part. Let me first continue with the bottom part. So the bottom part first is a tiller. It will be attached with an adjustable screw and a rotator. It's for the motion of the tiller. Second, we have the seed sower. It will be attached along with the front wheels. It will be having rotator for circular motion and small holes at regular intervals for seed sowing. And comes to the upper part, we have water and pesticide pumps for water and pesticide spraying. These pumps will be operating on two energies. That is, first is solar energy. Like the areas with hot climate and good sunshine, we can use solar energy over there. And the other one is battery. Areas with cloudy and windy climate, or whenever there is rainy season, we can use this battery part. And the other we have the battery, solar panel, and the voltage regulator. This will be help for the operation of pumps. We have tried to make some models on CAMD. I will like my partner to show that. So basically, this is the model we have designed. So this is the tiller for digging the ground, and this is the seed sower for seed sowing at regular intervals. This is tank for the reservoir for the water and pesticide, and this is the washer for the adjustable screw and nuts. And now I will like to use the mom thing which we have think about that to fabricate our machine and all. So the engine and the generator part and the pumps component can be made of an aluminum alloy matrix that is reinforced with aluminum and carbon fibers. Thus, we will get metal matrix composite, which is lightweight and resist wear and thermal distortion. Polymer matrix composite can be used in tires and intrinsic part as belts, hoses, as well as the automotive bodies. For body, we will use some carbon fiber reinforced polymer matrix composite. Can also be used in body panels as well as engine parts. This will help to reduce the weight, and the most importantly, PMC will have high strength, stiffness, and toughness. And this is the prototype which we used, like we sketched. So this is how it will look. And now I will like Somesh to continue forward with the electronics part.
Very good afternoon to one and all. Our system also consists a part where we'll be using the mechanical and the rotational energy of the wheel, converting it into electrical energy for charging of the mobile phones, which is shown through a flow chart. So basically, the system consists of a small generator that will provide power and will help the mobile phones to charge. As the wheel rotate against the tire, the motion produces electricity, and thus greater the speed, greater the output voltage. This output voltage will be fed to the rectifier to convert AC signal to DC, thus obtaining steady positive current as shown in the flowchart. This is now fed to the capacitor, which levels out the DC voltage, producing steady voltage inflow to voltage regulator. The voltage regulator is a crucial part because the phone requires nearly 3 to 4 volts to charge, and the voltage generated through the wheels will be very high. So we are using a voltage regulator to regulate the voltage for the charging of the mobile phones. Now, I would like to hand it over to Chiran for advantages and applications.
Yeah, this is Chiran, and I'll be explaining advantages and applications of this machine. First, I'll go with the advantages. This machine is compact in size, which means small in size, and this makes user friendly, and no special skills are required to operate this machine, and it has less maintenance cost. And we all know that if any machine has less maintenance cost or less productive cost, it might have huge demand in the market. And quiet running and smooth operation is also achieved, which means it doesn't make much noise while operating. And effective principle is also employed, which that is by the rotation of wheels, mechanical energy is converted into electrical energy, and it is used to charge our mobile phones. By using solar panel, electricity is also saved. Mobile phones can be simultaneously charged, and the power banks are not required. Coming back to the applications, this is used by farmers, which makes their work easier. And even today in India, many villages are not supplied with electricity. So while they work with this machine in the field, they can simultaneously charge their mobile phones. And even this charging application can be added in normal bicycles and other types of vehicles also. Now Vivekananda will explain the limitations and how to overcome it.
Good afternoon, everyone. I'm Vivekanand. I'll be explaining the limitations of our machine. The first thing is our machine is very small, and hence and it is also manually operated. So what happens is the efficiency decreases. And one more thing about the small size is that we cannot cover large fields. Few farmlands which are spread in acres, such fields cannot be covered. It is really, really difficult because the machine is too small. And we also use the sprayers to spray water and pesticides. So what happens is sometimes there are air gaps formed. This is also one of the limitation of our machine. Now we'll see how to overcome these limitations which I just listed. The problem which I told, the limitation was that we cannot cover large fields. So what we can do is we can just mount our machine to a tractor, and the tractor we can cover the whole field using the using the tractor. Even acres of land also can be covered. So that is how we can overcome the limitation. One more limitation which I mentioned earlier was the air gaps. What we can do is just when the air gaps are formed, we can just forcefully spray out the water once or twice so that the air gaps just come out. The same thing can be done with the pesticides sprayer as well, and that's how we have decided to overcome the limitations. Now Somesh will cover the rest. Somesh.
So actually, we all of us were in different geographical areas, so it was difficult to make a model. But still, we have tried to make a demonstration model, and this is the video of our model. So I would request everybody to please have a look to the video. Hello everyone. We are students of third SEM Mechanical Engineering. We propose to make a multi-purpose agriculture machine which will do tilling, seed sowing, water irrigation. This mechanism will also be used for spraying of insecticides as well as pesticides. It will also be used for mobile charging. So and our group includes Bhavna DV, Vivekananda Vijay Kumar, Anu Pratap Singh, Chirant PT, and me, Somesh Kumar. The methodology which we have decided is we have attached a tiller at the bottom part so that while moving, this will be used for tilling of the ground. A seed sower is attached, which has holes at regular intervals, so that we to make sure that the seeds are dropped at regular intervals and sowed properly. A pump, a water reservoir is placed with a pump, which is a suction pump, which will use to pump the water and will be sprayed to the grounds as the ground will get thick and the seed will be sown. Now, our vision is also to do using a generator. The motion of the rotation of the generator will create output voltage. This output voltage will be fed to the rectifier, and using this rectified voltage, which is converted from AC to DC. This DC voltage will be fed to a capacitor for leveling out of the DC voltage and to obtain a positive steady voltage. This using a voltage regulator, the voltage generated will be so high, this voltage will be dropped down and will be used for charging of the mobile phones. As of now, because of the lockdown and because of everybody is in different geographical areas, we cannot come together and do this. So the electronics part, we are not able to do it for a mobile charging, but we have used it for making the bulb glow. Means we just wanted to demonstrate that our power which is generated is used for glowing a bulb, which can be seen. So this is our process, and this is how it will be attached, and power is used for generation, and this is used for lighting of a smoke bulb. Now we also have done the survey. We have went to a farm and done the survey how it will be helpful for the farmers when this our product comes into market. So I would like Vivekananda to play the survey video. There's a bit editing in that. Hello, I'm Somesh, and regarding our project, we have came for a survey in our farm, and will like to take a small review of how people working in the farm and how our project, our machine will be helpful for them. So let's come with us. Hello, sir. Hello. So here is our youngest farmer. Even he attends the online classes like us. Yes, I do. So we are from BMS IT, Avalahalli. Okay. And we are mechanical engineering students. Okay. And we have made a machine, okay, which will do tilling, which will do seed sowing, which will do irrigation, spraying of insecticides, pesticides, and a very big plus point of our machine is it is also used for charging on the mobile phone. Oh, that's great. As you know, mobile phone is such important, now in small scenarios. So I would like to show you some pictures, like how our machine, this is how the tilling part it will be doing. Okay. This is the seed sowing, okay, and the water irrigation through the pumps. Okay. And this is how your
mobile will get charged. Okay. We use 2 to 3 machines for irrigation, but you have made 2 to 3 in just one machine. I'm really so impressed about that. Can I know what are the advantages of that? This machine at a time will do all that we know. Second, it is easy to maintain. Okay. It is used by anybody. Lots of labor will be, it will be lot less labor will be consumed for this. That's good. So I think it's even a time-saving process. Time-saving process. That's great. Charge my phone very often. I think this idea may work very good for me. Actually, and even our farm is located at a remote area. Yeah. There will be a lot of power cuts, and it is so important. It is very useful for me. Actually. Yeah, even you don't need to use additional power bank. The system itself, while doing its work, will generate electricity, will convert it into that much amount of voltage which is required for your phone, and your phone will get charged along with doing the work. By the way, can we use it for large lands? As you can see. Yeah. Even our machine seems this is just a demonstration model, but as you see, our large land is large. Okay. We will be mounting it on a tractor so that it will be used for even large lands also. So, sir, do you have any queries regarding this machine? No, not at all. I'm really so impressive about your Thank you so much. Machine. Yes, I think I'll be the first to adopt that machine when it gets into market. Yes, sir. Thank you. Thank you so much. All ready for that? Thank you so much, sir, even for your valuable time which you have given us for our PBL project. It's okay. Thank you, sir.
Uh, so now I would like to discuss about the cost of the machine. I would request Vivekananda to show the cost slide. See, the cost of the machine, generally our machine requires a few components like tiller, seed sower, and the material choice which we are doing is the reinforcement materials. So on by and large, the cost we keep it around 12,000 to 15,000, because other additional components like nuts and bolts will also be required to assemble those parts. A machine which is a capital, which are the four factors of production that are land, labor, capital, and entrepreneurship. So land will earn the rent, the labor will earn the wages, the machine which is the capital, the picture which is seen, the machine which is the capital will require to produce. Moreover, the profit, because anything which is produced has to earn profit for the economy to work. So even profit will also be added. So determining all the factors and all the parts, we feel we try to keep it somewhere around 15,000. And now I would like to discuss what are the spillovers of our machine on the economy part. I would like Vivekananda to present that slide. The economy after the pandemic is a very crippled economy. As we know, India is basically dependent on large part on agricultural sector. Still, with the given resources, human, physical, and natural resources, it is not well developed. The reason might be because of the fragmented land holdings, marginalized farmings, and obsolete technology, and disguised unemployment. Disguised unemployment is the biggest disadvantages that is happening nowadays. The disguised unemployment is something, it is an economic term. I would like to bit explain. It is something where on same land, entire family are working, still after the productivities will be same when it will be used when it is done by the machine. So those people without earning any wages are working on the land with the same productivity if they would have employed a machine. So what will happen is, now using the machine, there will be more number of people available to work. So with a bit of skill and training, there will be increase in the people who will be able to work in the informal sector, public sector, or private sector. As we know, as the more number of employment is there is more purchasing power in the hands of people, and demand will increase. With increase in demand, production of the any product will increase. Thus again, there will be more employment to produce the product. Thus again, there will be more purchasing power. This is how the GDP of the country increases, the net national product of the country increases, and this is how the economy grows. So, and I would also like to put some light on how we are trying to use the mechanics of material concept in our project. As for calculating the stress, for calculating the how much amount of strain will be acting, we are using the mechanics of material composites so that we know every product on a stress strain diagram will go and when it is plotted has an elastic limit, proportional limit. So we try to calculate the proportional limit, also try to calculate the elastic limit and the yield elastic points, which are the 2 points on the stress strain curve, so that we know under this we should the stress should be under this much range. Even we have tried to calculate the fracture, the how at what point the fracture of the machine might occur. So this is how we have related it to mechanics of material also, and through the selection of the products like ceramic material, reinforcement materials, how to make it light, how to make it more thermal and wear resistant. We have tried to use the material mechanics of material and material science concepts. So thank you everyone for lending your ears and listening to our PPT. Thank you so much.
Yeah, excellent work, Somesh and team. A nice presentation too.
Thank you, sir.
I have certain clarifications, Somesh. Are you targeting only for a particular crop for this equipment?
No, sir. This is actually for tilling and seed sowing and water irrigation. So this is not for a particular crop, not for any rabi, kharif or cash crop. It can be done for any of the crops which requires seed sowing, which requires tilling, and every crop requires tilling and seed sowing.
Okay, that's
and
okay.
water
But
irrigation.
with a little bit knowledge of farming, I think the distance between the two seeds will be differs from crop to crop, right? Is it safe?
Yes.
Sir,
yes,
we
sir.
can
Like
adjust the tiller size, sir.
Sorry?
Yes,
We
sir.
can adjust the tiller size. We can use
tiller size as well as along with the tiller size, the distance between the seeds which will be dropped, the distance between the each holes in the seed sower. So that can be regulated, and for each crop it can be done.
Now, how do you regulate that? Is there any design modifications you need to bring?
Sir, actually, sir, like we have not, the land will be not be similar every part of the country. Like, so we will be like have some adjustable screws and all, the washers and all for that, like different lands. Like we know the India is vast and have different kind of lands everywhere. So depending on that, we will be using our machine.
Okay.
Like different screws and
Moreover,
parts.
sir, we have tried to modeled on the solid edge. I have modeled it on the solid edge, the seed sower. So there, how in the design process, I can regulate at what distance. I would like to Vivekananda to show the slide once where I have modeled the seed sower part.
Okay, not an issue.
Where
Not an issue.
equal distances, I have placed the holes and then the cutout, so that the holes are created through cutout.
Okay,
it's totally
and a small
adjustable.
opening is made for the seed. And small opening is made in the seed sower, that square part, for the seeds to be dropped. And this is at regular intervals, so that gaps we can increase, and even the tiller size can be regulated.
Yeah, that's what I'm talking about.
Yes,
so
sir.
you have to
We can make any adjustment.
Yeah, you have to bring some kind of changes to be bring to the tillers as well as the sowers, so that for different crops you can use this machine. Am I right?
Yes, sir.
Okay. What is the maximum speed at which that wheels rotate? Have you worked out anything? Because you are using that for charging the mobile also, right?
Sir, if we keep it around 500 RPM,
500
I think
RPM?
it will be able to, at least 100 RPM, if it will be able to even charge the mobile phone.
No, is it manually operated? It is how it operates?
Yes, it is manually operated, sir. It is
Manually only, sir.
Unless it is operated with the hands, we can push and do on the small land holdings. If it is done on the tractor, then another design which we will be calculating the rotation that is, and the power, that is P is equal to 2 pi nt by 60. We can calculate we calculate that. So we can calculate even that part.
No, 500 RPM. How much you will going to get the velocity?
I think we will need to work on this, because it was manual. Right now we are doing it manually. We have this thought is just a thought on putting it on the tractor and doing it. That is limitations which have tried to come over. So as of now,
No, why I'm talking is because there is some threshold speed at which the wheel should rotate so that it can charge the mobiles also.
Yes,
Okay.
sir.
Yes, sir. We will work on it, sir.
Yeah, so please look it out. That is
Yes, sir.
excellent work. You please don't leave this. So please continue with these things. Okay.
Yes, sir. We will
Excellent
do it.
presentation from everybody. So
Thank
keep
you,
it up.
sir.
Okay.
Thank you. Thank you so much, sir.
Thank you.
Okay.
Thank you.
Thank you. Thank you.
Thank you,
That's it
sir.
from my side, ma'am.
Yes, sir.
Yeah. Kiran, sir?
Yeah, actually excellent work. So when you are showing the seed sower is there.
Yes,
Hello?
sir.
Yeah.
Yes, sir.
In that, so dropping of seeds, how you are going to
Yes, sir.
control that quantity? Is there
Sir,
any mechanism to control the quantity?
sir, we can attach something which is sort of a rod through which plates are attached, through which seeds can fall in such a manner that they are equally distributed and falling it from the holes
Yeah,
inside of the
actually, no, no.
mechanism that will
My thing
rotate
is,
along with the wheel.
yeah,
Yes, sir.
actually, you can search in YouTube. So you
Yes,
will
sir.
get you will get that is simple mechanism. You can attach that seed sower mechanism to wheel, so
Yes, sir.
that
Gear mechanism.
seed will drop depends on wheel speed.
Oh, yes, sir.
Yeah. If
Yes,
it
sir.
is faster, so you should feed more seeds. If you are moving the component slow, yeah, the slower speed, so you should feed lesser seeds, right?
Yes, sir.
Sir,
Through
sir,
Yeah.
gear
actually, it's
mechanism
like
which are attached to the wheels of the system,
yes,
the
sir.
seat
Our
sower.
seat sower is already attached with the front wheels, so according to that,
Okay.
we will work.
Yeah. Actually, if you are now you are made the prototype, right?
Yes, sir.
Yes, sir.
Yeah. Yeah, but excellent work. So, what would be the cost if you are made the one medium quantity manual operated
So it
one?
was 12K to 15K for
Yeah,
now.
along with
And sir,
your
if it is for larger land, we will discuss about it later.
if it is 12, 10 to 12 to 15K means what is the length you can get? Hello?
So what is
Yes, sir.
the length?
Now you said that 12 to 15K, right? The cost.
Yes,
So
Yes.
sir.
what is the length you can get? The seats or length and all the things.
Sir,
But
when I have modeled it on the solid edge, I took it as 150 and then done the
150,
revolve protrusion.
150
150
mm.
and I did the revolve protrusion.
Okay.
But as of now, when we are doing it on the
No. Now you are done prototype, right?
so prototype is that the seat sower which we have made, sir, that is made up of a
Yeah.
soft cardboard sort of material which we have
Okay.
attached it over there. So that is
Yeah.
also small and compact. We have done
Okay.
so much.
Yeah, I think now definitely it is a wonderful equipment. So if you made
Yes.
that using proper material with that double size, what you have done
Yes.
prototype,
Yes,
right?
sir. So when
That
we will
double
go for
size
the
is
proper
double
prototype, we
size
will
is
share it.
enough. Double
Yes,
size
sir.
is
Yes.
enough. So because I also came from agriculture background, so I used to work even weekend and holidays.
Yes.
Yes, sir.
So that's only I'm telling you, if you've done that double size, okay, it will be
Yes, sir.
wonderful. And so, is there any particular size of the seed?
So
Sides
that
of
can be
size of the
adjusted, sir. Like not proper about that. Like we can adjust it. Like how
Yeah,
much,
yeah.
like
Actually,
according to
size of it will be
no,
adjusted.
no, no, no.
We'll
You
make it
see,
adjustable.
you said correctly. You said that it is depends on the region we can use.
Yes,
So
sir.
if you came to
Areas.
yes,
here in South Karnataka region, they are going to crop more ragi.
Yes,
There,
sir.
ragi.
there, they
Yes,
are till that there they are facing that feed this one this problem to how we are going to feed the seed. Earlier days they are going to use the manual. Okay, now also they are facing.
one
If you have
one
done
mm to two
properly,
mm diameter holes we can keep. 1 mm to 2 mm
yeah.
diameter holes we can keep.
I think if you keep the 3 mm diameter hole, that's enough.
Yes,
Yeah, that's enough. You can do that.
that's what I was.
So
You
once we
can.
all guys
Uh,
meet and then we'll do it.
Yeah,
that
definitely,
depends
Make a
on
definitely.
proper
Because
prototype of it.
one
area.
more thing. Yeah, why I'm telling all those things means my brother has owned its company of this agriculture equipment. That's only I used to see the equipments when I
Okay.
gone to there. That's only I told you. So definitely it is the wonderful equipment.
Yes.
Till today, I didn't saw that. Even I saw in some net and somewhere, it is cost is very high. It is more than 1 lakh rupees, even if it is manual operated. Okay, so
Yes,
Okay.
sir.
that's only it is wonderful component. So you can do take forward this one.
Yes, sir. We'll surely do that.
Yeah.
Yes, sir.
Yes.
If it is
Yes,
possible,
sir. Even
please share that video to my personal mobile number.
Yes, sir. We
Yes.
will do.
yes, sir.
Yes,
I have your
sir.
number, sir. Kiran, sir, I
Yeah.
have your number. I'll share it to you.
Okay, okay then. Okay then. Somesh, I
Even,
think
sir,
you
I
have
yes, sir.
you share. Okay, nice
Yes,
one,
sir.
nice
Even
one.
our guide, ma'am,
Thank you.
Nandini ma'am, even has told us to take it front with fabrication and all, if it
Yeah,
possible.
that's
She
only
told us.
if you done with this, I will help with the fabrication. So you can do
Yes,
that.
sure, sir. Sure, sir.
Okay,
Yes,
okay,
sir.
Thank you,
okay,
sir.
okay.
Thank you so much, sir.
Okay.
Thank you, sir.
That's all, madam.
Yes, sir. So very good work, Somesh and team. Please carry on. Don't leave it. Take all the insights which was given from Kiran sir as well as Sundesh sir. So still try to build up a better one in your future. Okay, so that it will be having all the requirements as you had thought and had you had planned earlier. Okay.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
madam.
sir.
Yes. 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 So thank you, everyone. So
Thank you so much, ma'am.
yes,
Thank you.
Yeah.
Thank you.
the next batch. Yes, Govardhan Rao is there.
Yes, ma'am.
Okay, Shrikant P.
Ma'am, I told them to come.
They
They'll
haven't
come.
come yet. Krishna Kirti.
No, ma'am.
Okay, yet to come. Fine, I'll just try with the next batch. Power generation using speed breaker by Shibam Manu Hariharan. I think Shibam is there. Shibam Manu Hariharan, Harshit Kumar,
Yes, ma'am.
Shubhanki.
Hello, yes, ma'am.
Yeah, Hariharan is there.
No, ma'am. We
Ma'am,
have
he's
only
not
three
in our
members
group.
in our group.
Hello,
Where is Harshit Kumar?
Ma'am, I'm present.
Okay.
Ma'am, we have only three members in our group. Me, Shibam, and Shubhankit.
You means Harshit
Yes, ma'am.
Kumar.
Shibam and Shubhankit.
Okay, what about the other two?
Ma'am, the other two didn't respond from the first day. They are not in our group.
They are not in your group.
No, ma'am, they didn't respond from the first day itself.
Ma'am, they didn't respond from the
Have
first day. That's why we haven't included them.
have they done any other project? These two
Ma'am,
together? No
ma'am, we
idea.
don't know. No, ma'am.
Okay. So then Kiran sir and Sundesh sir, they say that only three people are there in the
Ma'am,
team.
just let them present. We will evaluate for these three persons
Okay.
only.
Okay, sir. Okay. So kindly proceed, Shiba.
yes, ma'am.
Okay, ma'am, I'm present.
Yeah.
Hello, hello.
Yes, you can please start.
Good afternoon, everyone. Now, myself, Shivam, Shubhankit, and Harshit will be presenting on our PBL project on electrical power generation using speed breaker. I would like to start by giving an introduction on the project. As we know that most of the energy requirement throughout the world is fulfilled by use of fossil fuels and other non-renewable resources. Hence, with time, these sources have depleted and are now nearing exhaustion. So our group has proposed a non-polluting power generating system in the form of a speed breaker mechanism. Uh, Basically, this modified speed breaker will convert kinetic energy into electricity when vehicles move on it.
Shivam, Shivam,
Hello, yes, sir.
your slides is not clear. Yeah, not visible properly.
Sir, actually, Harshit is presenting. Hello,
Okay, Harshit.
Harshit.
Harshit,
Yes, sir.
it's not clearly visible. Yeah,
Sir, on my phone it is clear.
your phone is clear, but for us, it's not clear here.
One
We
second, sir.
cannot read the sentences properly.
One second, ma'am. I will try. Ma'am, is it visible now?
No, no, it should be zoomed out little bit.
Zoomed out. Okay, ma'am. Now?
Zoom.
No.
Zoom in. No, no, it has to be wider.
Okay, ma'am.
Zoom in, zoom in.
Zoom in. Okay.
Yeah,
Now,
yeah. Now it's
now, okay.
right.
Yeah.
Okay. Now, do I start over or?
Yeah, you can please start.
Nandini madam, ಎಲ್ಲ ಬಂದಿದ್ದಾರಾ ನಮ್ಗೆ?
Yes, sir.
Everybody is present in.
In this group, actually, there are two absentees, Manu Hariharan and Pavan Kalyan. They say that from the day one, they haven't shown any interest in doing the work.
Okay, okay, right. Not an issue.
Yeah.
Okay. You can start, Shivam.
Ma'am, do I do restart?
Yeah,
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 yeah.
please.
Okay. Okay, I'll start. Good afternoon, everyone. Now, myself, Shivam Borkutoki, Shubhankit, and Harshit will be presenting on our PBL project, which is based on the topic electrical power generation using speed breaker. I would start by giving an introduction on the project. So, as we know that most of the energy requirement throughout the world is fulfilled by use of fossil fuels and other non-renewable sources. Hence, with time these sources have depleted and they are now nearing exhaustion. Now we are in need of alternate sources of energy. So our group has proposed a non-polluting power generating system in the form of a speed breaker mechanism. Basically, this modified speed breaker will convert kinetic energy into electricity when vehicles move on it. The methodology of this speed braking system is simple as it basically converts one form of energy into another. Uh, and in this case, kinetic energy is converted to rotational energy, and rotational energy is converted to electrical energy. So, when vehicles pass on the speed breaker, it pushes it downward, and this in turn rotates a gear connected to it via a hydraulic press. Also, the speed breaker is supported by a spring mechanism, and the gear which is connected to a AC generator by a shaft produces electrical energy. Go to next slide. Uh, this is a diagram of the speed breaking mechanism. Now, my friend Harshit will be speaking on system designs and functions.
Good morning, teachers. I am Harshit Kumar, and I am here to present the system design and function. So this speed breaker basically generate electricity when a vehicle passes through it. The when the vehicle passes through it, it pushes the speed breaker downwards. One rod is connected to the speed breaker, and the other end of this rod is connected to the uh, hydraulic press, which is connected to a smaller piston. When this piston when we apply force to this piston, it multiplies that force 4 times and gives out through a larger piston, which works on the principle of Pascal's law. Um, uh, then the larger piston moves the uh, rack and pinion, which converts this force into rotational force, and
Then rotational force is ab- supplied to the power the AC motor, which in turns uh, uh, which in turns generates electricity. And we have also put a charging circuit to charge the battery. And system construction. So basically, while designing this project, we thought of a system that is extremely simple to build and cost effective. So we tried to use as less parts as possible. So the first part of our design is the speed breaker itself. It is made up of iron and covered with vulcanized rubber. It will push the rod, which in turn will push the hydraulic press. We have also put a spring arrangement which will place back the speed breaker once the load of the vehicle is removed from the speed breaker. Hydraulic press is a simple force applied on a column of a liquid is converted to a much greater force applied to another column of the liquid. And rack and pinion can convert rotation to linear form of energy. And rack is a linear gear and pinion is a circular gear. This is a simple diagram showing the charging circuit. We have also put a dark sensing circuit so that when it senses dark, it can switch on the lights which are connected to the circuit. We have put a flywheel also. The primary function of flywheel is to act as an energy accumulator. It reduces the fluctuation in speed. It absorbs the energy when demand is less and releases the same when it is required. It is made up of nodular iron or stainless steel. Generator. The This device is used to generate electricity. Here is a small circuit diagram of the dark sensing circuit. We have also put a circuit inverter circuit and step up transformer. This circuit will convert the DC voltage to AC voltage, and the step up transformer will step up the AC current from 15 volts to 250 volts so that it can be used in various purpose. This is the diagram of inverted circuit and step up transformer. And now I will hand over the mic to my friend Shubhankit. He will explain the advantages and he will conclude.
Good afternoon, respected teachers. I'm here to give some advantages of this system. First of all, this system has very simple construction with a very simple technology. And the best part, this system does not require very high cost for establishing it, and also has very less maintenance cost also. It's a non-conventional energy sources that are used in the system. It also requires very less working field, thus it does not obstruct the daily running roads. At last, the main disadvantage is the system is the that it is the power grid is directly proportional to the running traffic. Coming to the conclusion, like we are taking step towards making our city more smarter day by day. Bringing this system would be more efficient and eco-friendly too, which does not bring any hassle to our environment. By this system, we can utilize the obtained power as in street lights. Also, it can be used in tool booths also. Nowadays, there are some automobile run on electric motor. Very famous company like Hyundai has started making electric cars. On establishing this type of image, we can charge electric vehicles. So I believe from every angle, this system is very effective, which will reduce this power crisis in India. So that's how I thank you.
Thank you, ma'am. That was our presentation. And ma'am, we have also presented We will also present a simple calculation to show the power output of this device. It is a approximate value. Let me show you. 1 second.
Okay.
Yes, ma'am. The average weight of a vehicle we took as 350 kgs. We plan to build the speed breaker of 15 centimeter high. So weight of body is equals to 350 into 9.8. That is equals to 3,430 newtons. So distance travel is equal to height of the speed breaker. That is equals to 15 centimeter. Work done is equals to weight of body into distance traveled by the pressure of vehicle. Power that is equals to work done upon time, that is equal, the final value of power is 8.58 watts. This power output is for one vehicle passed over it. So if we take an average, if for 60 minutes the total power output of the system will be around 514 watts. So approximately it can glow up 100 watt CFL bulbs for 6 hours or more if we connect this to 6 power bulbs.
That's it?
Yes, ma'am.
Okay. How did you decide the mass of the vehicle to be 350 kg? Did you do?
Ma'am, that's an approximate value we took. So basically, many bikes that we use in India are below 350 kgs, but we took 350 because of car and all. We took an average value for that.
Have you done any survey on it, literature survey part? A
Yes,
background
ma'am.
study?
Yes, ma'am. We saw many
Now we have taken
we saw many projects
the
of this kind, but the main problem was with that projects that they required more money to build. So our theme was to build a system that will be cheaper to build and more easier to operate with less chances of wear and tear. So that's why that's it different in our project.
Okay, but still you have to see like how the others have designed. So how yours will be economical with the good performance. Both should go hand in hand,
Yes,
right?
ma'am.
Yes, ma'am.
Okay, so you have to see and look into those aspects also.
Okay, ma'am.
And still more effort need to be done to see in
Yes,
actual.
ma'am. We plan to build a physical model, ma'am, but due to the geographical location of our team members, we are not able to build the model because our model is very complicated for one person to build. It requires manpower to
Yeah,
design
so
and build.
yes, so you please take care and do it in your near future. Okay.
Yes, ma'am. We will carry this
yes,
project
ma'am.
forward in our fifth SEM.
Yes. So that's all from my end, sir. Sudresh, sir.
Oh, nothing, madam. You can carry.
Yes, sir. Kiran, sir.
Nothing, madam. Okay.
Okay, okay, sir. Okay, then, Harshit and team.
Thank you,
Thank you.
ma'am.
Yes,
Yeah.
ma'am.
Thank you, ma'am.
Thank you so much, ma'am. Have
Thank
a
you,
nice
teachers,
day,
so
ma'am.
much.
Thank
Yeah.
you, teachers.
I think the last batch now, Govardhan and team, you people are there. Govardhan Rao.
Ma'am, two teams are left, I think.
Yeah.
Govardhan Rao. No, no. Okay, okay. Last.
Last, no, sir.
Yeah, last one. Last.
We can see only
Yeah, I'm
Govardhan here. Govardhan, hello.
yes, ma'am.
Where are your friends?
They are not responding, ma'am.
Whether they'll be coming or not? Are you
Ma'am,
are
2 minutes,
yeah?
ma'am. I'll call them and
You told that time only you will call and let me know. ಇವ್ರು ಯಾರು ಬಂದಿಲ್ಲ.
ಯಾರಿದ್ದಾರೆ
ಸೊ 4 ಜನದಲ್ಲಿ ಒಬ್ನೇ ಇದ್ದಾನೆ ಗೋವರ್ಧನ್ ರಾವ್.
ಓಕೆ ಇವನ್ ಬಿಡಿ ಮೇಡಮ್ ದೋರ್ಜಮ್ ಮೊತ್ತ ಬರೋ ಡೌಟು
ಮಾಡಕ್ ಹೇಳದ
ಆದರ್ಶ್ ಗೌತಮ್ ಡೌಟ್ ಇದ್ದಾನೆ ಯಾಕೆ ಬರ್ತಾ ಇಲ್ಲ ಅವನು ಕೃಷ್ಣ ಕೀರ್ತಿನೂ ಡೌಟು ಇವರಿಬ್ಬರೇ ಶ್ರೀಕಾಂತ್ ಪಿ ಎಷ್ಟು ಕಮ್ ಗೋವರ್ಧನ್ Madam, we will continue, madam. Let them Siam will give. That's it.
Okay, Siam, you please present. Siam, you are ready with the presentation? You are ready with the presentation?
Yes.
Kindly,
Yes,
please
ma'am.
start. Please start.
Ma'am, but no one is there in my group over here.
Siam,
It's okay.
if you present, you will get a marks. If they are present, they are getting the marks. Okay. Got it, Siam? Hello.
Yes, sir.
Can you hear me?
Yes, sir.
So it is individual.
Yes, sir. I can hear.
Individual mark will be awarded. If you are present, you will get a marks, and if not there, then you go to lose the marks. Okay, it is already well in advance. We are informed everybody to present. Am I right? It is already 3 o'clock. Still, they are not bothered to join. You go ahead. Do you have presentation with you?
Yes.
Govardhan, is the presentation is with you? PPTs are with you?
Yes, sir. Yes.
Yeah, you can start presenting.
Sayam, you please start. I called Shrikant, is not picking the phone. He is not interested, I feel. You please carry on with your work.
How this can be
You are not audible, Govardhan, properly.
No, ma'am.
Hello. Hello. Govardhan, you please present your work.
Govardhan, don't be scared. Don't wait for others. Do your presentation and finish it. Mom's contribution is individually, right? They're all waiting to finish your presentation.
Siam, what you are waiting for, Siam?
Oh, no, he left only.
Yes, sir. Hey, you are not that okay.
What is this?
These people are yesterday whole day something like that. Just finish it off.
Yes, sir. Yeah, you just call him. Let me see. Sir, 2 minutes, sir. Nitya ma'am is calling him. Let me see what he tells.
Sure.
What happened when? Why you left the call? Okay, come back soon. They're waiting. How long they'll wait? Keep join fast. It's coming with the network issue.
Okay, he'll be back, sir. Some network issue, it seems. He'll be back.
Okay.
Okay.
Then I think you're wasting your time.
What he told?
We said network issue and trying for connection.
Blindly also.
That is Nitya ಮಾತಾಡ್ತೀನಿ. ನಿತ್ಯ. ಸರ್ ನೀವು ಟೆಲಿಕಾಮ್ ಲಕ್ಷಣ ಸಾಗುತ್ತಲ್ಲ. ಓ ಸಾರಿ ಸರ್ ಒಂದು ನಿಮಿಷ.
Govardhan, did you logged in? Oh, yeah, yeah. Please do the presentation. We are waiting. Be good. Sayam, kindly do start.
ಹಲೋ ಹೇಳಿ ಸರ್. ಏನಿದೆ ಸರ್?
Where is the PPT?
ಹೌದು FID FTP ಅಂತಾನೆ ಕೊಟ್ಟಿದ್ದೀರಾ.
Can you see this?
ನೀವು FTP
I can't see the PPT. You please share the PPT.
Nandini madam.
Yes, sir.
5 minutes madam, Bartim, please go ahead. I will come.
Aitu, sir.
Okay, I will add it. Okay, okay, okay. Uh, okay, done, done, done. Okay.
Sayam, you know how to share the screen?
I know.
Yeah, please be quick. We are
Can you
getting delayed.
see
It is
now?
3:15. No, no,
Can you see now, ma'am?
there is no PPT as such. You have to go for present now. In that, you have to go for a window. Then you have to share your PPT. Before that, you have to keep your PPT on. Then you open your Google Meet. Until then, you minimize your Google Meet window. First, keep open your PPT on your screen. Then you maximize the Google Meet
Yes.
window. Then you go for present now. Click a window and share your PPT.
Now.
Sayam, no PPT still.
Hello, ಕೇಳಿಸ್ತಾ sir?
Now it is visible.
ನಾನು ನಿತ್ಯ ಮೆಕ್ಯಾನಿಕಲ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಇಂದ ಸರ್ ಈಗ ಬರಲ್ಲ ನನ್ನ
Yeah, go for slideshow. Click on slideshow.
ಹೌದಾ ಎಷ್ಟೊತ್ತಿಗೆ ಬಂದು ಕಲೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸರ್ 4 ಗಂಟೆಗೆ ಹೊರಡಕ್ ಮುಂಚೆ ಬಂದು ಕಲೆಕ್ಟ್ ನಾಳೆ ಕೊಡ್ತೀರಾ ಓಕೆ ನಾಳೆ 10:30 ನಿಲ್ಸ್ಕೊತೀನಿ ಓಕೆ ಸರ್
If you are not able to click on slideshow, kindly do start as it is, no problem.
ಓಕೆ
Sayam,
Yes, ma'am. I heard.
please start.
Ma'am, the topic are group noise sources, the the different machines, what kind of noise will create and how the noise will varies. Industrial industrial machinery is composed of various gases, gas, and with fluid flow processes, critical machines, mechanisms of noise generation depends on the particular IC operations, equipment including crushing,
Voice audible ಇಲ್ಲ correct.
riveting,
Yeah, please continue.
shakeout,
Continue.
pump, product. Noise is therefore a common hazard. A large number of workplaces such as and steel industry, foundries,
ಓಕೆ ಬನ್ನಿ
oil mills, airports, and aircraft maintenance shops, crushing mills, among many others. In many countries, noise-induced hearing loss is one of the most prevalent occupational diseases. Industrial noise sources. The sound pressure level generated depends on the type of from the source to the receiver and of working environment. For a given machine, the sound pressure levels depends on the part of total mechanical or electric energy that is found in sound is usually detected due to the pattern of many surfaces, propagation of air through solids, diffraction at the machinery boundaries, healing environment surfaces, absorption of the extra. have a more cost effective from the point of view of machine manufacturers. This generally means offering products with the low space, material, energy, and production of time requirement. At the same time, account is being taken increasingly of resource conservation and environmental friendliness, although the rise in noise levels, which frequently goes along with increased output and productivity, it often overlooked, is all mechanical
ಮೇಡಮ್ ಇವನೇನ್ ಮಾಡಲ್ವಾ?
ಹಲೋ
ಮೇಡಮ್ ಏನ್ ಕತೆ ಒಂದು?
ಇವನೇನೋ ಒಂಚೂರು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ದ, ಅದೇನ್ ಮಾಡ್ದ ಅದು ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ. ಈಗ ತಿರ್ಗಾ ಹೊಟ್ಟೋಗ್ಬಿಟ್ಟ. ಏನ್ ಅವ್ನಿಗೆ ಎಷ್ಟು ಮಿನಿಮಮ್ ಏನ್ ಕೊಡ್ಬೋದು ಅಷ್ಟು ಕೊಟ್ಟು ವೈಂಡ್ ಅಪ್ ಮಾಡದ ಸರ್?
ನೋಡಿ ಮೇಡಮ್ ಏನ್ ಮಾಡೋದು.
ಸುಂದ್ರೆ ಸರ್ ಎಲ್ಲ ಹೋಗಿ ಬರ್ತೀನಿ ಅಂದ್ರು 5 minutes.
Hello?
Why did you leave the maid, Govardhan?
I didn't leave, ma'am.
Then
I think network.
who will ask you the questions? No. Kindly join. Hello, Sam. Hello. Yeah,
Yes,
was
ma'am.
your PPT completed? Was that much only? Hello.
Some more is remaining.
What?
Some more is remaining. Some more
Some more is
remaining, ma'am.
remaining. Please, will you continue?
Yes, ma'am.
Please be quick. We are like 23 minutes behind you. Please complete. Share the screen again.
Madam, one more batch, that Darshan or Madhu P batch is given.
Darshan. Sir, guide us really.
Sri Ganesh.
Oh, correct. ಇವ್ರದ್ದು ಬಂದಿಲ್ಲ ಅಲ್ಲ ಸರ್?
ಇಲ್ಲ ಬಂದಿಲ್ಲ ಅದಕ್ಕೇನೆ.
ಇವ್ರದ್ದು ಯಾರ್ದು ಕಾಂಟ್ಯಾಕ್ಟ್ ನಂಬರ್ ಇಲ್ಲ. ಶ್ರೀ ಗಣೇಶ್ ಸರ್ಗೆ ಫೋನ್ ಮಾಡಿ ಕೇಳಬೇಕು. I'll call Ganesh sir. Sayam, you please continue.
Compressive, very easy machines with high power. Noise sources are caused by trapping a definite volume of fluid and moving it around case to the outlet with higher pressure. The short pulses from compressor are quite severe, equivalent sound pressure levels that can exceed 105 decibels. The emitted from compressor is periodic with noise generators are generally discrete, low pressure frequency put on broadband cooling system. Typically, motor converts electric energy to and then mechanical energy with other
Hello, Govardhan. Govardhan. Hello. Sir, I called Ganesh sir. He told ಅವರಿಗೆ phone ಮಾಡಿ he will get back to me.
Okay, madam. Then we will start another 5-10 minutes, madam. We'll have
Yes, sir. Yes, sir. Yes, sir. Yes, sir.